Cek 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 cek. Cek satu-satu dicoba cek cek. Cek satu-satu dicoba, cek satu-satu dicoba. Cek cek cek. Tes satu-satu. Nah, ini lebih enak lagi dari yang tadi. Terima kasih.
Ho, ho, ci, ci, ha,
dulu apa gimana ya? Nanti aja ya.
ci, ha.
Ini berarti ubur rampe saya tak pindahnya.
Baik Bapak sekalian, selamat datang. Selamat malam, silahkan nanti akan ada sesi foto-foto bersama. Kami persilahkan untuk kenyamanan Bapak Ibu semuanya, silahkan untuk duduk terlebih dahulu. Baik, kami juga mengucapkan selamat malam dan selamat datang Ibu Menteri sudah hadir di sini. Dan Bapak Ibu segenap tamu undangan sekalian, selamat malam dan juga selamat datang dalam acara sidang disertasi virtual Mas Nel Andika. Nanti akan ada sesi foto bersama dengan Mas Nel. Dan untuk kenyamanan Bapak Ibu semuanya, karena foto bersama nanti akan dibagi menjadi beberapa sesi, Bapak Ibu bisa duduk terlebih dahulu sambil menanti sesi foto bersama. Silahkan, nama-nama sudah tertera di kursi yang sudah kami sediakan. Baik, Mas Nel Andika, kami persilahkan untuk bisa menyiapkan diri di depan. Kami akan mengajak Bapak Ibu tamu undangan yang sudah hadir di sini untuk foto bersama dengan Mas Nel. Silahkan Mas Nel mungkin bisa bersiap-siap untuk menuju ke depan terlebih dahulu. Baik, Mas Nel sudah siap di depan dan untuk itu tamu undangan yang sudah hadir di sini saya mohon untuk juga menuju ke depan. Dari Universitas Gajah Mada, Bapak Panut Mulyono, Bapak Bambang Agus Kironoto, Bapak Muhammad Waziz Wildan, dan Bapak Sugeng Sabto Suryono. Silahkan sudah hadir di sini untuk ikut dalam sesi foto pertama bersama dengan Mas Nel Andika. Baik, terima kasih. Untuk sesi foto berikutnya kami undang juga dari Universitas Gajah Mada, Bapak Rohmadi, Bapak Teuku Faisal Fatani, Bapak Ali Awaludin, Bapak Budi Santoso Wiknyo Soekarto, dan Bapak Danang Parikesit. Ya, silahkan segenap tamu undangan yang kami sebutkan baru saja untuk menuju ke depan untuk foto bersama dengan Mas Nel Andika. Baik, untuk foto sesi ketiga, kami undang dari Kementerian PUPR, Bapak Agung Budi Waskito, Bapak Dwi Purwantoro, Bapak Satrio Sugeng Prayetno, dan Bapak Nazib Faisal. Silakan, bila sudah hadir di tempat ini kami mengundang Bapak dari Kementerian PUPR untuk menuju ke depan foto bersama. Bapak Agung, Bapak Dwi, Bapak Satrio, dan Bapak Nazib Faisal. Baik, untuk sesi foto selanjutnya kami mengundang Bapak Jeffrey, Bapak Leo, dan Bapak Chandra Kristanto dari Kementerian PUPR. Oh ya, oke. Ya, untuk selanjutnya sesi foto bersama dengan keluarga, Bapak dan Ibu Basuki serta Mbak Aziza, silahkan untuk ke depan.
Kenapa? Oh, yang di ini mungkin nggak semuanya ya.
Halo, halo. Halo, halo. Halo, halo. Sini. Halo, halo. Kurang kencang ya?
Agak di ke atasin gitu untuk mic-nya.
Oh, ini ke samping ya?
Maaf ya Mas ya.
Apa di dasi? Kejauhan.
Coba.
Halo, halo.
Maaf ya Mas ya.
Ya.
Oke. Coba.
Halo, halo. Nabrak-nabrak. Bentar, gak enak nih dilihat pemirsa di rumah. Makanya. Agak nabrak. Kalau nunduk tapi kena juga.
Atau mau pakai face shield?
Enggak mas, jangan.
Ya.
Makanya face shield terus nggak pakai masker.
Face shield aja nggak tanpa masker begitu.
Jangan ya.
Oke.
Sebenarnya nggak tahu nanti boleh nggak sih nggak pakai masker? Harus pakai masker.
Kalau pakai face shield di
Halo.
muka sih pasti kedengaran jelas. Face shield nih pakai face shield.
Permisi Pak, bantu. Sudah? Maaf ya Mas ya.
Yes bos. Ini lagi tes. Ditarik dikit biar nggak kelihatan. Ya.
Ya. Ini ya.
Oh ya harusnya sebelah kanan. Aduh bos.
Satunya.
Kebalik ya sebelah situ.
Oh, balik.
Sebelah kiri.
Ini gaya presenter ini dah.
Lu ke acara ini udah kelas ini nih. OPG. Sini dari mana?
Siap.
Ya udah di nggak apa-apain.
Kecuali nanti dosenmu kurang jelas dari
Kalau nggak jelas alasannya ya pakai masker sana. Kelihatan tapi salah kayaknya. Apa itu benar? Salah kan?
buat nanti kan ada timernya masnya itu masnya ngomong 30 menit biar masnya
Itu
bisa ngeliat
beda kan?
jam ini
Jam tuh di atas.
atau di sini ditaruh ada jam biar masnya bisa lihat.
Di sini ya. Tak ambil aja deh. Apa tak benerin apa?
Jadi biar bisa ngatur waktu bicara.
Halo, halo. Halo, tes 1 2 3. Oke deh tapi.
Coba mas mau mas.
Halo, tes 1 2 3.
Kalau dinaikin,
Kayak presenter beneran ya? Halo, tes 1 2 3. Kembali lagi bersama kami. Halo, selamat malam. Kembali lagi bersama saya, Andika. Halo, tes 1 2 3.
coba kalau di masker
Halo, tes 1 2 3. Buka aja lah kayaknya. Ini ngalangin nafasnya nih jadi embun kacamata.
Gue nanti di bawah nyemprotin ini deh. Iya buka ini buka aja. Suara jelas itu kan kita orang virtual semua.
Ini banyak yang di sini, Mas Rio, banyak itu.
Suara itu. Kalau ini ngomong langsung gitu. Nah, ganteng kalau gini. Ya nggak, Mbak Ica? Ganteng kan kalau gini kan?
Ya dilihat-liatin aja sih.
Jam 10 ya mas, jam 10 pas.
Kayaknya masih salah, enggak?
Di belakangin aja mas dulu ya.
Oh, ya, siap.
Mas, aku samping ya.
Siap. Ya.
Coba lagi mas. Yang di bawah ya.
Yang di Zoom. Halo. Halo.
Agak keras lagi.
Halo, selamat malam. Cek 1 2 3. 1 2 3. Yang di Zoom katanya kecil. Kecil nggak? Zoom-nya oke. Di sana kali speakernya kecil. Di rumah. Zoom oke kedengeran. Baik, terima kasih. Ada yang chat tadi.
Mas jahe nggak? Jahe.
Enggak apa-apa. Thank you.
Ya, di YouTube sudah. Coba kita tes suara yang di YouTube nanti Mas, boleh?
Halo, tes 1 2 3. Tes 1 2 3.
morning.
Good morning, Dr. Julian.
Good
Can you hear
morning,
me?
Neil.
Good morning, Dr. Julian. Malam, Mas Neil.
Malam, Mr. Robert. We have Dr.
Yeah.
Julian
Hello,
here
Robert
already.
Kuduwati.
Yes, how are you?
Good. How are you doing?
Fine. And
Oh,
you?
I see you now. Okay, nice.
So we are night, you are morning, yeah?
Yeah. Let's
You-
see here.
We are night, you are morning. You are
All
morning.
right, it's early. It's 8 o'clock here in the morning. I guess it must be 8 at night there in Indonesia.
Yes,
Yeah,
okay.
It's almost
Halo
10
Pak,
o'clock.
halo Pak Tribeko.
Is this Friday or Saturday for you?
Oh, still Friday.
Friday night.
Still
yeah.
Friday. Okay,
Friday
Friday
night.
night. Oh, instead of a party, then you're doing a defense,
Video
right?
saya kayaknya freeze ya atau gimana?
So how are you, Dr. Julian?
Oh, good. I try to stay healthy. I teach one class on Zoom this semester.
Video saya
and
kayaknya
It's
nge-freeze ya.
very different from normal teaching, I guess.
Okay, same with me. So with online teaching, yeah, not offline.
Yeah, I try to go for walks every day, just to get out of the house. Other than that, I work mostly from home, and I go to the office maybe twice a week for the essentials, but it's different times for sure. Our numbers are starting to get a little bit better here. Vaccination is underway, though I've not been vaccinated yet, and we're hope that by March that we'll get vaccinated.
Okay. We are starting, but only for the health staff, yeah, not yet for the public, yeah.
Yeah. So, good. How's teaching at is it Surabaya?
No. I am in Semarang, in Central Java.
Semarang. Yes, exactly.
And Mas Nil is in Jogja.
Uh-huh.
Hey, can you see me now, Dr. Julian?
Oh yeah.
I'm sorry,
Yeah,
Neil.
yeah, we can see you.
Can you see me, Dr. Julian?
Yes, Mas Nil.
Yes, I can see you. Yes.
Nice.
Yeah, we'll start when we get the committee all together, right? So I'm glad you invited many, many people. I mean, I did this wonderful. And I'm just waiting to see Dr. Edema. We have Dr. Edema, Dr. Grigg, Professor Grigg, and Dr. Sarah Radburn from Geosciences, who has been, faculty here for quite some time, and she has a lot of experience with material geomorphology. And so I don't know, Neil, maybe you can introduce some of the key people that you have invited and who are in attendance there. I see there are 24 participants now, I think 28 at this point.
Yes. All right. Can the cameraman shoot to the VVIP attendees in here? Mas bisa bantu disorot? So, actually we have as you know, my father as the Minister of the Public Works. And yeah, and then we also have the president of Universitas Gadjah Mada. We have, he's the president of Universitas Gadjah Mada. We also have the vice president for the human resources, I think. Yeah, for the Universitas Gadjah Mada. And then we also have the Dean of the Faculty of Engineering. Yeah, and then we also have the department head of the Civil and Environmental Engineering too. Yes, and then we also have my lecturers from my undergraduate time. I have Mr. Budi Wigno, Professor Budi Wigno, and then we have Professor Danang Parikesit. We also have Professor Suryo. Yeah, and then we also have Professor Pak Ali, the Professor Ali, yeah. And then yeah, we have some people from the government, from the Ministry of Public Works too in here, and also from one of the private company in Indonesia. So yeah. Yes, maybe we need a microphone for. We need microphone, I think.
I see Dr. Radburn on the roster here. I don't know if Sarah is there.
Good morning.
Good morning. How are you doing?
I'm all right. How are you doing?
Good. Are you in Fort Collins?
Yes, and I'm even in my office at the university.
Oh, okay.
It's just been very hard to get much work done at home.
That's very special.
Yes.
So thank you for all your comments on the dissertation. And I'll say a few words of introduction in a minute here. I'm waiting for Neil Grigg and Professor Grigg and Dr. Edema to join in, and we'll make this official. So
That works. Thank you.
hey, Dr. SIdoarjo, Honorable.
Hello, Professor Julian.
Yes.
This is me, Basuki.
Yes. Yeah, Bazuki. We know you as Mr. Bazuki, but you know, you're such an honorable person in Indonesia.
Yeah.
It's great to see you.
And also, I invite some CSU alumni, like Professor Triweko, Professor Seno Darsono, and then also Robert Kodoati from the Ponegoro University, and also Dr. Nanang. He's in Bandung right now. Thank you very much, Ms. Julian, for giving my son, Neil, to have the exam tonight, or this evening, this morning. Again, for all the committee members, as an alumni of CSU, I would like to say thank you very much for giving this opportunity. I cannot imagine that if my son will have this kind of opportunity to have the exam. So again, thank you very much for all your guidance and also everything that you have touched to my family life. And also for CSU that also raised me up like this now. So again, thank you very much, Pak Greg, Pak Julian, Mr. Julian, Dr. Sarah, and Dr. Itema. Thank you.
Thank you very much. We're really appreciative of the great attendance and all the great work that you have done in Indonesia. I remember I was there a couple of years ago, and I remember driving by kind of roundabout there where there was a huge poster there with your accomplishments and all the work that you have done with the Ministry of Transportation and Housing and Development there in Indonesia. It is for us at CSU an honor to have had someone like you come here and do your PhD graduate studies with Dr. Grigg, and take this knowledge and technology and transfer this to Indonesia and take part into a huge economic development for your country. For us, I mean, this is what keeps us working. You know, at CSU, we're teaching and trying to do our best and whatnot. And we have several international dignitaries like you who have returned to their countries. We have the courage to go back there and face the reality and really improve the you know, the economic status of all the people in their own countries, and contributed tremendously to the development of water resources. I can think of you in Indonesia. I can think of Dr. Kodawati. I remember Dr. Jayamurni Wargadalam also, who made some significant contribution. Jaya was very close to my heart because I was very saddened with the recent news about him, and I called him Jaya, as you know, and he's done so much good work with us there in the morphology of rivers there in the early 90s, and he also contributed to the development of irrigation in your country. So let's see, Dr. Edema is there, so I'd like to maybe can unmute and say a few words.
Well, good morning, everybody.
Good morning.
Good morning, Dr.
Good morning.
Morning.
Good morning.
And I'm looking for Neil Grigg. I don't know if he's on board yet.
No, I'm here, Pierre.
Already.
Neil, I see you. Wonderful, wonderful.
I say
Neil,
hello. I see Basuki. He looks so distinguished and healthy. I'm glad to see you looking so good.
Hello, Dr. Greg. Thank you very much. I hope you are in a healthy condition now.
I am, yeah. Maybe I'm a little older than you are, but I'm still going, so I expect you to go too.
Good morning, Professor Craig.
Yeah, I also see Robertus up there. I haven't
this
seen
is
you for
Robertus.
many years.
Okay. So on the way.
Yeah, you look just as young as you did when you were here, working to solve the problems of Jakarta, all the urban water problems of Jakarta. I think maybe you got all those solved, and now you can finish some other problems.
Well, very good. Pierre Julien have been the advisor to Neil Andika, and we welcome all the dignitaries and all the official people from Indonesia, and also here in Fort Collins there to participate in this dissertation defense. I think your presence raises the stake on our candidate, Neil Andika, and shows the importance of the passage from a master's to a PhD, and it really is an accomplishment also in your life. So the procedure, since the degree is going to be awarded here at CSU, and we appreciate all the great work that's been done at University Gadjah Mada to make this venue possible over there, and through Zoom, actually, to be able to communicate and be together for this event. But we will follow the procedure from CSU regarding our graduate school. So typically here we have a committee member composed of the advisor, that would be me, and two professors from the department, that is in this case Professor Neil Grigg and Professor Rob Edema from the Department of Civil and Environmental Engineering. And our graduate school procedure requires one candidate from, one faculty member from outside the department, and that is Professor Sarah Radburn from the Geosciences Department. And so the procedure, I'll explain the procedure a little bit. So typically what we do, we allow the candidate, some 30 minutes or so to give a presentation to highlight the achievements or the accomplishment of the PhD dissertation work, present this to the public, after which we will have an open door question there from the broader audience. So at this point, everybody in the audience can ask a question to the candidate. And once this is completed, then we will have a closed door committee meeting with the candidate, and then, to discuss the details, and, we do a bit of laundry cleaning there together regarding the dissertation and the presentation and so forth, after which then we convene and present the result of the exam to the candidate. So the process should take a couple hours or so. And at this point, I would like to invite Neil Andika, our candidate, to give a presentation. Neil has been with me for about 4 or 5 years. Things got delayed a little bit because of the COVID. And when I visited the University Gadjah Mada, that may be 6, 7 years ago, I met with Professor Joko Legono. Pak Joko was very kind to me, invited me to go there, and he's the one who told me for the first time about the SIdoarjo mud volcano, and he said, well, you know, there's water coming from the ground at 1 cubic meter per second, and about a third of it is solids, and we don't know what to do with this thing. And so I got interested in the topic, and when Neil came here and looked for a topic, I said, well, how about this topic? And then he took the ball and ran with this, and he did a tremendous job. And I'll turn this over to Neil now to give his formal presentation.
Okay, thank you very much, Dr. Julian. Once again, good morning to all attendees in Fort Collins, Colorado. And good evening to all VVIP attendees in here, start from the Minister of the Public Works and Housing of the Republic of Indonesia, and then the President of the Universitas Gadjah Mada, the Dean of the Faculty Engineering, and the Department Head of the Civil and Environmental Engineering, and all attendees that present in here, and also that join us via Zoom meeting. Before I start my presentation, once again, I would like to say thank you to Dr. Julian and my committee member for allowing me to have this online Ph.D Defense. And I would like to thank Universitas Gadjah Mada for allowing me to have defense in this room in my hometown university. Today's topic, I will present about my research that I've been working with Dr. Julian about the propagation of the SIdoarjo mud in Porong River, East Java, Indonesia. Here's the brief outline of today's presentation. I would like to start by giving you the introduction of my research, and then I will describe a little bit about the site or the study reach, and then I will talk about the properties of the SIdoarjo mud. And then we will discuss about the field measurement programs that I did a couple of years ago. And as the last analysis, I will talk about the computational modeling about the sediment propagation. And I will close my presentation by giving you all about the conclusion of my research. First, the introduction. I will be talk about the background and then what's the problem due to the SIdoarjo mud volcano, and also what the objective of my research. As we all know, SIdoarjo mud volcano firstly erupted on May 29th of May 2006. So it's almost 15 years from now. And it's erupted in Porong, East Java. Based on the data from the Ministry of Public Works and Housing of the Republic of Indonesia in 2007, the impacted area is about 650 hectares. It includes the mud reservoir, as you can see in the background of the slides, and also the surrounding area that is very prone to the land subsidence. And then the total economic loss on 2008 is about $560 million because there's so much social impact due to the SIdoarjo mud volcano. For example, it forced at least 30,000 refugees and then buried about 10,000 houses and also destroyed a lot of companies and infrastructures. Actually, there are two main arguments about the cause of the SIdoarjo mud volcano. The first one is because of the natural disaster due to the Yogyakarta earthquake that happened on May 27th, 2006. This argument supported by Mazzini, a researcher from Italy that still come to Indonesia, to the SIdoarjo mud volcano once every year. And the other arguments is that the mud volcano was caused by the drilling failure by the oil company PT Lapindo Brantas. This argument was supported by Davis and Tingai and most of the petroleum expertise all over the world. The source of the extracted mud comes from the from 1.6 to 1.8 kilometers underneath the soil. And usually it's dominated by the smectite and followed by quartz and feldspar. Smectite itself is actually a silicate structure that's very useful for many fields. For example, like for cosmetic, for medicine, for grouting, for molding, and also for the drilling mud. And then several researchers also tried to study about the flow rate of the SIdoarjo mud volcano. For example, Mazzini stated that in early years, the eruption rate can reach up to 180,000 cubic meter per day. But nowadays, this discharge is about 50 to 60,000 cubic meter per day. And here is the plan view of the SIdoarjo mud volcano. The left picture shows us the picture from 2006. In here you can see that the impacted area at that time was around 130 hectares, and the government tried to contain the mud volcano with the mud reservoir. And yeah, the government still tried to relocate a lot of people from the surrounding area so that the damage can be mitigated. And then the middle picture is the picture from 2010. You can see that the mud reservoir has been constructed and it's already contained the mud volcano. And then the right picture is from 2018. As you can see that the mud reservoir has been filled up by the mud. And in some area, the mud has been consolidated so we can step on it. And the government actually tried to divert some of the mud, start from the November 2006 to the Madura Strait through the Porong River. The Porong River is in the picture indicated by the blue arrow at the bottom of the picture, at the south of the mud reservoir. And due to the mud diversion, some problems occurred in the Porong River. For example, the total diverted mixture from the outlet is about 1.6 million cubic meter per month, with the sediment concentration can reach up to 57,000 milligram per liter. Because of the huge number, of sediment concentration and number of diverted mixture, then sediment concentration monitoring is urgently needed in the Porong River, and also the sediment propagation need to be we need to understand the sediment propagation in the Porong River so that we can mitigate the further damage to the ecological life in the Porong River. So from those problems, we derive three objectives. The first one is that we would like to determine the properties of the mud released into the Porong River, and then we would like to carry out field measurement programs to capture and understand the concentration distribution in the Porong River. And last, we would like to develop a computational model for the sediment propagation in Porong River. Okay, here's the site description. So first one is the mud reservoir, which is, as said before, it actually has an area of about 560 hectares with a perimeter about 11 kilometers. From the mud reservoir, the government used two main pipelines to divert the mud to the Porong River. The first pipeline is started from the point 25 or pin 25 with the outlet called Pejarakan Outlet or PO. And then the second pipeline is from the point 43 to the outlet Ginonjo Outlet or GO. The Porong River itself, for our study reach, has a length of about 15.8 kilometers, as indicated by the bold blue line in the bottom pictures. And note that we have a Porong station just upstream of the Pejarakan Outlet, where we can collect the flow rate data of the Porong River. Okay, several studies about the Porong River. Degradation usually occurs in the wet season. As you know, it's from November to April, and while aggradation usually occurs during the dry season, it's from June to November. However, this aggradation and degradation interaction will not affect the flood capacity of the Porong River. And talking about the environmental perspective, the allowed total suspended sediment, or TSS, for Porong River is 50 milligram per liter, based on the regulation number 82 of 2001, where the Porong River classified as class 2 river. But actually the observed TSS along Porong River was higher due to the mud diversion. For example, a study from the Yenarian in 2013 stated that the sediment concentration can reach up to 970 milligram per liter. Then for our research, we focus mainly on 3 flow conditions based on the flow duration curve that I show you in the slides. The first flow is the low flow, which has a discharge about 45 cubic meter per second, which usually occurs in the dry season. And then the second flow is the medium flow, which is about 250 cubic meter per second. And the high flow is 2,500 cubic meter per second, which usually only occurs in the extreme conditions. And here's some hydraulic properties of the site. This is the typical cross-section. At the bottom picture shows the typical cross-section of the Porong River. Actually, we have a sheet pile on the left bank and the right bank, but due to sedimentation, particularly in the first kilometer of the Porong of our study reach, then the shape of the cross-section became irregular. For example, for low flow, we have a flow rate of about 45 cubic meter per second. And with that discharge, we have an average flow depth of about 3.5 meter. And then the top width is about 105 meter with the flow velocity of 0.12 meter per second and the shear velocity of about 0.01 meter per second. Then we talk about the properties of SIdoarjo volcano, but in this case, particularly we're talking about the particle size distribution and then the relationship between the turbidity and sediment concentration and also the flocculation processes in Porong River. Okay, we did the particle size distribution analysis in the ITS in Surabaya. So we took 3 samples, one from the extruded mud from the main crater, and then one from the diverted mud in Penjarakan outlet, and one sample from the Ginonjo outlet. And from there, we found that the extruded mud actually coarser than the diverted mud, either from the Penjarakan and from the Ginonjo. We think that the finer sediment in the diverted mud of Penjarakan and Ginonjo outlet may be because of the resuspension, because we use dredger to divert the mud from the mud reservoir into the Porong River. And then we also measure the relationship between turbidity and sediment concentration. Why we use turbidity? Because turbidity is usually easier to collect. Yeah, it's easier to collect the turbidity data than the sediment concentration because we require less time and require less amount of sample to collect the data of the turbidity. However, the relationship of turbidity and sediment concentration can change spatially and temporally. In our cases, we did a laboratory experiment to create the relationship between the turbidity and sediment concentration. And we found that sediment concentration in Porong River is equal to 5.3 times turbidity plus 24. And then we also try to compare our results with the previous study, and our results actually at the located in the middle of all the previous study. Note that our relationship is a linear relationship, but some in previous study we can also found that there is a relationship in the exponential equation. And then last, we're talking about the flocculation. So flocculation is actually a phenomena where a very fine sediment tends to hold and stick together due to their electrochemical behavior. And to test the flocculation processes in our river, we use the flocculant agent, which chemical agent that force the sediment to disperse. And so to test, we took 4 samples from the outlet. So 2 from Penjarakan outlet, we call it P1 and P2, and then 2 from the Ginonjo outlet, we call it G1 and G2. Okay, and then we add the deflocculant agent into P2 and G2. Hypothetically, if the flocculation happens in our river, then the settling velocity of the natural sample should be higher than the sample with the deflocculant. Okay, and in fact, that's what happened in our river, in our sample. The settling velocity of P1 was 0.032 millimeter per second, while the P2 has a settling velocity of about 0.015 millimeters. So it also happens for the sample from the Ginonjo outlet. So then we can conclude that flocculation happens in Porong River in interaction with the diverted mud. Okay, the second analysis is about the field measurement programs. So actually, me with the crew from the PPLS in the SIdoarjo, did at least 2 field measurement programs. The first field measurement program was done on July 2018. At this occasion, we collect the sample from 1 meter under the water surface, and we measure at least 106 cross-section, with the distance between cross-section is about 150 meters. Note that we have 4-point measurements for each cross-section. So actually we have about 400 or 450 samples in here, and we measure or collect the turbidity data from here. And actually, we also collect the turbidity data from upstream of the outlet, so we can capture the turbidity or the sediment concentration before the diversion from the mud reservoir. And the upstream sediment concentration is actually almost 57 milligram per liter. And then in our study reach, the highest measured concentration for line C is about 4,200 milligram per liter, and for line D is about 2,700 milligram per liter, followed by line B and line A. Okay, and beyond 3 kilometers, we reach the fully mixed sediment concentration, where the concentration all across the Porong River stay the same, which is around 90 milligram per liters. And, we can also see from the graph that there are so many high sediment concentration at the first 3 kilometers. That's why we are curious to see if there is a lot of sedimentation in the first 3 kilometers. That's why we did another field measurement program, which we did in September 2019. Yeah. So in this field measurement program, we try to capture the vertical sediment concentration profile. We also did for 4 line. For example, in cross-section 1 consists of 1A, 1B, 1C, and 1D. But due to sedimentation in the left bank and the right bank, the vertical sediment concentration profile was not very good at the line A and line D. That's why we focus on the line B and line C, where for the line B, the two highest sediment concentration was located at the 200 meters downstream of the Porong River, where the concentration was 700 milligram per liter at 6 meter depth, and 400 milligram per liter at 4 meter depth. And for line C, the highest sediment concentration was recorded at 1 kilometer downstream of the Indonesia outlet, with the sediment concentration of about 1,500 milligram per liter at 6 meter depth and 1,450 milligram per liter at 3 meter depth. And then we also try to understand what is the Roche number for our vertical sedimentation profile. As you can see, we focus on 6 profiles, which has data for at least 4 point of measurements. For example, in cross-section 1B, we have about 5 measurements at the water surface, or Z equal to 0, and then Z equal to 1, Z equal to 2, Z equal to 3, and Z equal to 4 meters. And most of these, the Roche number from these 6 profiles, most of them are bigger than 0.5. That's why we can categorize our river has a mixed load. It's not only suspension, but also some bed load in the first 3 kilometers. So it's called mixed load. So then the third analysis is about the computational sediment propagation model in the Porong River. There are 3 scenarios. The first one is the 2-dimensional model without settling. And then the second scenario, we add the settling factors. And then the third scenario, we added the flocculation processes into our model. So the basic of our first scenario is the complete 3-dimensional advection diffusion equation, which is stated in the slide. The first term, the partial derivative of C over time, indicates the mass change of the concentration. And then the second, third, and the fourth term of the equation of the left-hand side indicates the advection terms of propagation. And then the C dot as the first term in the right-hand side indicates or is applied for the non-conservative substance. For example, for sediments that settled, or also for the pollutant or contaminant that decaying over the time and over the space. So from this equation, we assume that the longitudinal advection and diffusion is very, we assume that it is much smaller than the advective term. That's why we can reduce it into two-dimensional advection and diffusion model. And then we also have the diffusion and turbulent mixing coefficient stated at KD for the longitudinal, and then the eta phi for the vertical, and eta t for the mixing coefficient transversally. Then we also have the length scale, XD, XV, and XT, and we also have the time scale, the TD, TD, TV, and TT. Okay, and then we use the analytical solution from Fisher, from his book about the inland and coastal propagation. In here, we use the solution for the straight natural channels with conservative substance, so C dot equals to 0. And we also consider the presence of left bank and right bank, so we call it the finite width. And the analytical solution is present on the slide, which is C over CB, where CB is the average sediment concentration or the condition where it's fully mixed, which equal to 1 over square root of 4 times pi times x prime, where x prime and y prime is the dimensionless coordinate of the point of interest, and y0 prime is the dimensionless coordinate of the location of injection. So the equation is pretty simple actually. So it's 1 over square root of 4 times pi times x prime times the summation of inside the bracket. And then the result of our model is present on the graph at the bottom of the slide. So for the low flow, actually the left one with the discharge of about 45 cubic meter per second, the sediment concentration at the right bank indicates with the blue line start very high at the first meters and then drop dramatically very fast to about equal to the fully mixed sediment concentration. In this case, it's about 470 milligram per liters, and it only takes about 3 kilometers to reach that state. Meanwhile, for the center line and the right bank of the river, the sediment concentration starts very low and it increased dramatically until the 3 kilometers, until it reached 3 kilometers. And another way to look at this is by using the surface graph. For example, for the low flow condition where the fully mixed sediment concentration transversally can be reached at 3 or 4 kilometers. It's equal to the length scale or xt. The sediment concentration at the mouth or at the end of the Porong River is around 470 milligram per liters. But initially, when it reached the river, it's around 2,000 or 3,000 milligram per liter. That's why we can see that there was about 76% loss of sediment across the study reach. Meanwhile, for the medium flow condition, there was about 84% of loss of the sediment across the Porong River. And for high flow condition, there were about 57% loss of the sediment across the Porong River. And then from our model without settling, we can see that from our observed data, we know that the fully mixed sediment concentration is about 90 milligram per liters, but from our model, the flow condition is about 470 milligram per liter. That's why there is about 380 milligram per liter differences. So we can say that this model we need to improve this model so it can predict the sediment propagation better. So that's why we added the settling factor to the model, which is comes from the decay equation, where the exponential of the minus k times t is equal to the c of the fraction I at the point g plus 1 over the c the sediment concentration of fraction I at the location g. Then we substitute it to the analytical solution we have before, and then we have the whole set of equation there in the middle. And then we also have, we calculate the sediment concentration by size fraction. So in order to understand the sediment propagation for each size fraction. So we can see which sediment fraction that settles in the first 3 kilometers and which one that still flow along with the Porong River, with the flow rate. And then the total sediment concentration from this model is indicated by the cyan line. So I think by the end of the Porong River, it still have about 200 milligram per liter. So we still have about 100 milligram per liter differences between our model and the observed data. That's why to improve our model, we added the flocculation processes to our river. The floc class can be defined by using the equation for Mignot and also from Winterwerp, where the settling velocity for a flocculated particle is equal to 250 divided by the ds square times the settling velocity. And then the result from our last model is indicated by the black line for the left bank, and it's agree or match very well with our observed data. So then we can conclude that this model can be used to predict the sediment propagation in the Porong River due to the mud diversion from the mud volcano. So we also confident that this can be used another time if there is many sedimentation, many diversion with very fine sediment into the Porong, into the river in general. And then we also see from our size fraction calculation that the gravel and sand fraction settled at the first 300 meters of the Porong River, while the silt fraction, for example, with the median grain size of 13 micrometer and 10 micrometer, mostly settled around 10 kilometers of the Porong River. Here's the table that summarizes our calculation, where in here, this is this size fraction based on our particle size distribution that we did in the ETS. We have 13 classes actually, and we add another class called the floc class with the sediment size of about 92 micrometer. The weight of the floc class is about 38% of the total sediment, and then the second highest class is actually the fraction of 75 micrometer with 12%. And both of the floc class and the fraction of the 75 micrometer have settled or usually settled at the first 500 meters in the river. That's why by the end of the Porong River, we only have clay fractions, only the clay fraction that have the median grain size of about 0.0 about 1.3 micrometer and also 1 micrometer, with the total of sediment concentration by the end of the Porong River of about 91 milligram per liter. And to conclude my presentation today, as for the first objective about the property of the mud, we found that the relationship between the turbidity and sediment concentration for the data from 2018 is concentration equals to 5 times 3, sedimentation equals to 5.3 times turbidity plus 24. And then the flocculation test resulted and can be concluded that mud tends to flocculate due to the settling velocity is higher for the natural sample. And then from our field measurement programs, we can understand that the average observed sediment concentration from the field measurement program is about 90 milligram per liter. And then from with the maximum measured sediment concentration, we're located at line C with 4,200 milligram per liter. And then the highest near-bed sediment concentration was at line C in the cross-section 9 with 1,500 milligram per liter, followed by line C at cross-section 6 with the 150 milligram per liter. And from these field measurements, we can conclude that the sediment concentration were uniform along the Porong River, except for the first 4 kilometers where a lot of sediment were settled in that area. And then from the modeling part, the mixing model without settling resulted that the fully mixed sediment concentration for low flow of about 470 milligram per liter and achieved at the 4 kilometer downstream of Ginonjo outlet. But this value is much higher than the observed sediment concentration with the 380 milligram per liters. And then that's why we added the settling factor into the model and also the flow calculation processes. And we can match our model with the observed data with the sediment concentration of about 90 milligram per liters. And we can see that only craft fractions that were in suspension by the end of the study reached, with the sediment concentration of about 24 milligram per liter for sediment grain size of 1.3 micrometer and about 54 milligram per liter for the particle with the size of about 1 micrometer. And before I conclude my presentation, I would like to acknowledge all of the contributors for my research. First, of course, Dr. Neil Grigg, Dr. Rob Etema, and Dr. Sarah Redburn for their feedback, and also collaborators, all of the Dr. Julian's research team from first time I joined the team until now. And also the LPDP, or Indonesian Endowment Fund for Education, for funding me throughout my master and doctoral degrees, and also Ministry of Public Works of the Republic Indonesia for all the sharing, including Mr. Aris Setiadi, Mr. Leo, and all the PPLS crew from Mr. Jeffrey, and then Mr. Dwi, and also Mr. Chandra, and all of the crew. And of course, Universitas Gadjah Mada for having me here today. And with that, thank you very much. I think you are still in mute, Dr. Julian.
Yes, thank you, Neil. Thank you for your nice presentation. That's very timely. You took about, what, 30 minutes or so. That's very, very nice. And so at this point, get a glass of water. I don't know, it's Friday. I don't know. But so we'll open this up to the broader audience there for questions. So at this point, I'd like to invite all the attendees to raise your hand, or actually maybe unmute and just ask a question to the candidate. We cannot hear the question. I think someone's asking a question from the audience there with you, Neil.
We are preparing the microphone to him. So.
Oh, I see. Yeah, the alternative. Okay, very good. Thank you.
Okay. Thank you very much. First of all, I would like to give a congratulations to Mr. Neil, because you have done a good work for your dissertation. I have a little bit a question about the work of PhD. For your presentation, I know that you have make a field measurement and try to compare with mathematical modeling. But I think there is how to say, actually you do not yet to consider the existence of bed load transport. I don't know if this is the limitation of your study, or maybe there is no bed load transport in the river, I mean in the Porong River. Maybe you can explain why you do not consider the bed load transport in your mathematical modeling. Thank you very much.
Okay, thank you very much. Can you hear the question, Dr. Julian?
Yes, I could hear the question.
Okay, should I just answer directly? Okay. Thank you very much for your question, Professor Bambang Agus Kironoto. So yeah, in a way, that is the limitation of my research, because I mostly only try to model the suspension or the suspended load of the sediment concentration. So at that time, I'm not really consider the presence of the bed load, the transport capacity of the transport of the bed load sediment, and in the short answer, yeah, that is the limitation of my research, and maybe yeah, that's the limitation of my research, and I only focus on the suspended sediment actually, because that's the most interesting part actually from the sediment concentration. And as we know, the diverted mud is mostly consists of the very fine sediment, which only appear in the suspension. That's why that is actually the main reason why I do not consider the bed load transport. Is that enough, Professor Bambang Agus Kironoto?
Okay, thank you. Do you think the result of mathematical modeling will give different result if you consider the bed load, the existence of bed load transport or not?
If I use this analytical solution from the Fisher's book, it's mainly only talking about the mixing in the river, which mixing is mostly consists of the suspended sediment, in my opinion. Yeah. So I don't think the mathematical model will change a lot if I added the bed load transport in this case.
Okay. Thank you very much. Yeah.
Can I have a question?
Yeah, Dr. Kodwadi.
Okay, Mr. Masnil, yeah. Call you Masnil. I have a short equation. How about the condition in the river mouth? If there is a tide, is there a change your modeling or the change the sediment concentration? Or is there any influence about the tide from the sea for your modeling and also for your analysis? Thank you.
Okay, thank you very much, Dr. Robert, for your interesting question. So yeah, actually we have actually the tide have a lot of effect to the Porong River, because we can see the effect into near the Ginonjo outlet. You know, it's because of the backwater and everything. So the presence of the tides, for example, if it has a high tide or low tide, it affect the flow velocity in the Porong River. But in terms of the sediment propagation, it's only it's not directly affected by the tides, because only the very fine sediments that we consider in this model, and based on the measured or the observed sediment concentration, we see that only the fraction of clay particles that propagate into the end of the Porong River. So usually based on my literature review, the very fine sediment concentration is actually not settled at the estuary, but actually a little bit further away from the Madura Strait. So that's why the tides, it's not directly affected the sediment propagation in the Porong River, except it's decreased the flow velocity and the hydraulic properties of the Porong River.
One question.
Yes.
You only consider the suspended load, yeah?
Yes.
How about the wash load?
Okay.
Did you consider the wash load?
So in our case, the wash loads usually come from the upstream conditions, where as we measured the sediment concentration upstream of the outlet is have about 57 milligram per liters. So that is already includes the wash load, and that's already that mix into the sediment that propagates throughout the Porong River.
That's right.
Yeah.
Okay, thank you. Thank you.
Thank you.
For your nice answer.
Other questions? We welcome questions. We love questions. There's somebody else in the audience trying to get the microphone, Neil?
I don't see it yet, but maybe someone wants to ask.
Maybe online, somebody? While waiting for questions, maybe I'll make a comment on the first question about the bed load. Actually, that's how we started. And Neil, it may be a little while ago, I mean, he's done so much work since that time, but he started with ECRAS and looking at the sediment transport and degradation you would get in the Porong River just using ECRAS, which is essentially based on bed load or bed material load equations. And that didn't lead us anywhere. So therefore, then we shifted gears and went into more the suspended load analysis that he presented here today. I think the question of tides also from Dr. Kudwati was very relevant there. I think you can see a little bit of fluctuations at the lower end of the profile there. And I think Neil attributed this to some fish farms that were in that area, and also possibly some tides that may impact also locally the sediment concentration. So I'm still waiting to get more questions from the broader audience here.
Oh, there's one question.
Okay, thank you for the occasion. Mr. Neil Andika, just small question for me. I'm geologist, so I just want to know considering about the season. Did you mention about the season of the Indonesia? Because this is rainy and so dry. So this will be influence of the river flow, the debit, I mean. So did you also calculate the model for the rainy season and the dry season for your sediment transport in your dissertation?
Okay, thank you.
Yeah, I think it's
thank you. Can you hear the question, Dr. Julian?
Yes, I did.
Okay. So for the answer, thank you very much for questions. So the answer is that we tried to calculate or to model the sediment propagation for several flow condition. Like I said, there are 3 flows, but the most interesting sediment propagation actually is for the low flow. Actually, as the flow rate getting decreased, then the sediment takes more time to flow from one point to the estuaries. So if it's like a rainy season, for example, with the discharge of about 250 cubic meter per second, the flow rate is about 0.2 or 0.3 meter per second. Then the sediment will go to the estuary faster, so it will first get washed by the flow. So then the sediment concentration will get fully mixed by the end of the Porong River, because there's only so little time for them to mix across the river. So then, they have the settlement will be a little bit longer than the low flow. It can reach up to the 8 kilometers. But I already considered, but I only present about the low flow because that's the most interesting part in this time. So yeah, I consider that, but I did not show it this time because limited of time. Thank you for the question.
Yes, that is correct, that the high flows are going to flush the sediment out. You dilute the amount of influx that you get from the SIdoarjo mud diversion there, and you're going to reduce the concentration. So maybe time for one last question, or? Well, very good. I want to thank you all, very much for your very careful attendance and listening to Neil's presentation this evening. For you, I think it's a unique opportunity for Neil to present in front of all the top faculty and the top leaders in Indonesia. So I think it's an opportunity for him to get his work known. And at this point, I will ask you to log out. This is the end of the public presentation of his dissertation defense. So I will ask you to log out, and with my sincere thanks and thank you to Minister Bazuki. And I think it's with great pride there that he should see his son. And I don't know, I'll give him his last opportunity, maybe if he wants to say something. I think it's an honor to have him with us today.
Okay, Dr. Julian, Dr. Greg, Dr. Robert, and Dr. Sarah, again, on behalf of the my personal and also from the Gadjah Mada University, I would like to say thank you very much for this opportunity. And if you allow me, I would like to ask the president of Gadjah Mada University to say something to the committee of the NIL, because NIL will be the lecturer of this university. If you allow me, I will give.
Absolutely.
Okay, thank you. This is the Professor Panut, the president of University of Gadjah Mada. Please.
Okay, thank you very much, Minister Basuki. Good morning, Professor Julian, and also the member of the committee. Thank you very much. And I would like to say congratulations to Neil, our young potential lecturer here, and we are very happy this night in Indonesia and this morning in United States that
we all here heard that his presentation is very excellent, and of course we thanks to the advisor and committee member of dissertation examination this morning or this night in Indonesia. And Professor Julian, I would like to ask you that Universitas Gadjah Mada want to engage with SIdoarjo to have collaboration and partnership for not only in the engineering field, but also for other field in your university, because Universitas Gadjah Mada is the very comprehensive university. We have all fields in Universitas Gadjah Mada. Again, thank you very much and congratulations for your guidance to our potential young lecturer who not longer than now will be granted, I think, Ph.D degree, yeah, from CSU. Thank you very much.
Thank you very much, President Padud. I think it's a great. I appreciate your invitation for collaboration. We enjoyed over the years a lot of collaboration with Indonesia, and among dignitaries what we see today. Dr. Bazuki is certainly the leader there. I remember Professor Kodwati Jayamurni Wargadalam, my late PhD student who passed away recently, and we offer condolences to his family, heartfelt condolences from all of us there. At CSU, we offer a variety of programs there in the water resources, water resources planning management being one, hydrology, hydraulics, groundwater, environmental engineering, geosciences, and watershed science, and so forth. And we like to think that we are relevant, and we work closely with international communities, and including Indonesia, Malaysia. I've been there many times. South Korea, I've known many South Koreans who work with us, and I've been there many times personally. And it is a bit unfortunate nowadays that we could not invite you people to come, and especially I remember that Minister SIdoarjo had the intent to come here for the graduation, and we wish we would hold the defense and the commencement ceremony here in Fort Collins. But we like to think that within a year and perhaps 6 months, we're going to return to normal, and we'll resume the ability to travel overseas and have bilateral exchanges between Indonesia and the United States. And we offer services to help the formation of newly minted graduate students, and we like to offer, a lot of programs there that may be helpful to the development of water resources in Indonesia. So with this, I think it's a nice point of conclusion. I'd like to thank the Honorable Bazuki and the President Panud and all the other dignitaries that are innumerable, and for your attendance this morning. I think it's very helpful to Neil Andika to see what real life is going to be about pretty soon. We're very proud to see that he's going to be one of the faculty at the University Gadjah Mada. I visited there, and I was so impressed with the number of students and the quality of the staff and the professors that are teaching there. It's one of the largest, if not the largest, university in Indonesia, and it certainly is a name that we recognize here in Fort Collins. And so with this, I appreciate your attendance this evening for you, this morning for us, and we'll ask you to leave, we want to move to the next phase, which will be a closed-door meeting with the candidate. And so thank you very much.
Thank you very much. Thank you. Thank you.
Thank you.
Bye-bye.
Stay healthy, and we'll see each other before too long.
You too.
Yes.
Terima kasih, Pak.